Can all of you hear me, ma? I'm gonna take down the following relations and find the possible candidate keys, ma. These two. All of you try to find out the possible candidate keys. Yes, ma, are you trying out the candidate keys? 72 for which it is AB and for which it is ABC, Amma? First question, ABC. Is AB a part of ABC, Amma? What is minimal in AB and ABC? Any other candidate keys? Okay. What about others? What about others, Ma? Second is AE. Okay, fine. Try the next two. All of you try the next two, Amma. third question. Yes, ma. Third question is B option. And fourth one is try to figure out the fourth one. There are still more, ma. Surya. Fourth one. Right. A, B, B, C, A, C. Shravya. Fine. Now try to do the fifth and sixth, ma. What about others, ma? Are you trying to do or no? You're just sitting idle. Roll number 7K. 7K. Are you in the class, ma? 7K. Six F. 6F. 6F. Not how many questions did you do, ma? Abhishek? Are you trying out or no? Did you get, how many did you get, ma, Abhishek? Okay, fine. Six M. 6M. M for Mumbai. 6N. 6N. Okay, are you facing any problem with finding out candidate keys, ma? ABC, DBC, fifth one. Right, ma? It's correct. Okay, any problems while you're working with finding candidate keys, all of you? Okay, now do you have any issues with 1NF and 2NF, ma? 1NF and 2NF. Which one you want, ma? Candidate key. What is the problem with candidate key, amma? 68? I hope you can see the notepad, ma? All of you? Now see, whenever you want to work with candidate keys, you're given with a relation and a set of attributes. You're given with a relation and set of attributes. Okay. Now, try to look at the functional dependencies which are given along with the relation capital R. Here, I'm working with R is equal to A, B, C, D, E as the attributes, and AB implies C, C implies D, B implies E are the functional dependencies. Okay. Now, what I have to do is I have to figure out the attributes which are not present on the RHS of the functional dependencies. So what I'm trying to do over here is I have C in the first FD, D in the second FD, E in the third FD as the RHS attributes. And the things which are not present in the RHS attributes are A, comma B. Okay, A and B. Now what I have to do is I have to find the AB closure. I have to find the AB closure. Okay, I have to find the AB closure. I have to find the closure of AB, which is equal to AB with respect to reflexive property. I'll be getting AB closure as AB. Now I have to see using these two, which are the other attributes I can generate. Using these two, which are the other attributes I can generate. So looking at these two, I've got AB implies C. AB implies C. So if at all I've got a value of AB, I can get the value of C. Now looking at the second functional dependency, once I have C, I can find the value of D. Once I have C, I can find the value of D. So I'll be able to write D also here in the closure, AB closure. Then if at all looking at the third functional dependency, I've got B implies C. So I've got already B value. I know the B value. So if at all I know the B value, I can know the E value. Now, anything else is left out? No. So what is closure of AB? AB closure is A, B, C, D, E. So I'm able to determine all the attributes of the relation capital R, which implies that AB is the candidate key. Now I'll go with one more option. I'll go with A. I want to find out the closure of A. I want to find the closure of A. What is closure of A? A. Is there anything I can get using A? I cannot get anything apart from that. Looking at the three FDs, I cannot get anything. So I can't say A is a candidate key. Now I'll go with B closure. What is B closure? With B, I'll be getting D. With B, I'll be getting E. Apart from this, I'm not able to get anything. So B, reflexive property of B is B. Then using the third FD, I'm able to generate E. So B closure is BE. I'm not able to get all the other things. Next, I'll be going with C. That way you have to go find out. Now what I'll do, I'll try to combine two attributes. AC, I'll go. What is AC closure? AC closure is reflexive property is AC. Then C determines D. Anything else can be determined? Nothing. So this way I have to work with candidate key. Is it okay, ma? 68? Is it okay? Still you have any problem? Fine. Amma, any other questions, ma? With respect to the basics of normalization, whatever the two normal forms have covered in the previous class? Okay. Now, I'll be going with the concept of 3NF. Okay. So, I've already told you this in the previous class. What is 3NF? Whenever I want a relation to be in 3NF, whenever I want a relation to be in 3NF, then I should have that particular relation capital R in 2NF, and there should be no concept of transitive dependency. There should be no concept of transitive dependency. Now, I'm taking a small example over here, R with ABCD as its attributes. Now, what I have to do is I have to figure out what is the candidate key of the relation. That is the reason I've just given you some questions to work out one. Now, what is the candidate key? I've got C and D as the RHS elements. So, there is a high chance of AB becoming a candidate key. So, I'll check AB. What is AB closure? Using AB, I'll get the value of AB. Using AB, I'm getting the value of C. And using C, I'm getting the value of D. Right? So, AB is a candidate key. Now, all of you know, the attributes that are part of candidate key are called as prime key attributes, which is nothing but A and B are prime key attributes, and C and D are non-prime attributes because they are not part of any of the candidate key. Now, you can look at it over here. CD. I'll just find out CD closure. What is CD closure? CD. That's it. I'm not getting any other attributes using CD. Now, if at all I want to individually check what is C closure, I'll get C, reflexive is C, then C implies D. That's it. Only two I'm getting. So, AB is my candidate key over here. Right. Now, AB implies C. There is no problem with this because AB is the candidate key and there's no problem with a candidate key determining another non-prime attribute, no issues. But C implies D. Is C a part of a primary key or your candidate key? No. So this is causing the violation. So transitive dependency occurs over here. When a transitive dependency occurs is when a non-prime attribute determines another non-prime attribute. When a non-prime attribute determines another non-prime attribute, it leads to the concept of transitive dependency. How it leads to the concept of transitive dependency, you can see over here. AB implies C. Then I've got C implies D. So this is the violation I was telling you. And using these two relationships, I can say AB implies C. Sorry, D. AB implies D. So using 1 and 2, I can directly say that AB is implying D. So this is the concept of your transitive dependency. This is the concept of your transitive dependency. Okay. Now what I have to do in order to make this relation, which is not in 3NF, into 3NF. What are the violations? That particular thing I am separating. So R1 is ABC, which is nothing but the first dependency, which is not causing any problem. So R1 with ABC and R2 with CD. Here what's happening? C becomes my key attribute and C implies D. There's no concept of transitive dependency over here. Okay. So this is the way I'm making a table into 3NF, which is not in 3NF. So what I'm trying to do over here is I'm trying to decompose the given relationship into two pieces. Is it okay, Amma? What is 3NF? What is 3NF? Is it okay? With an example. Now see, a table with some sort of data. Table with some sort of data. R is ABC and the functional dependencies are A implies B and B implies C. A implies B and B implies C. What is the key attribute? What is the candidate key? I've written over there. A is the candidate key. A is equal to reflexive property is A. If at all I've got the value of A using the first FD, I'll get the value B. And using the second dependency, I'll get the value C. So A is my candidate key. And I'm just giving some values for ABC over here, Amma. Now, again, what is the problem? The first FD, A implies B. A is the candidate key and B is non-prime key attribute. So this does not cause any problem. Now, whenever I'm working with the second functional dependency, look over here. B is a non-prime key attribute, which is determining another non-prime key attribute. So this is the concept of your transitive dependency. This is the concept of your transitive dependency. Now, easily you can again work. A implies B, not an issue. B implies C is a problem which is giving me A implies B. A implies B. So this particular concept is causing the violation. Now what I have to do? I have to break this table. My R1 would be AB, these two things which are not causing any problem. My R2 would be these two, which is causing a problem. So I've written over here. Now R1 is AB, R2 is B. Here what happens? B becomes the key attribute and B implies C, not an issue. And there is no concept of transitive dependency in the broken pieces. There's no concept of transitive dependency because there are only two attributes. Okay. Now see, another way of looking at 3NF is a relation R is in 3NF. A relation R is in 3NF if for every dependency A implies B. If for every dependency A implies B, either A is a super key or B is a prime attribute. A is a super key or B is a prime attribute. You need not check the things which we checked earlier. You can directly look at the functional dependency and see whether the LHS is a super key or indirectly you can say it's a candidate key followed by the RHS is a prime attribute. Because whenever we have this kind of thing, there is no concept of partial dependency. Because in partial dependency, a prime attribute is determining a non-prime attribute. A prime attribute is determining a non-prime attribute. And it cannot be transitive also. Because whenever transitive dependency is there, only a non-prime attribute is determining another non-prime attribute. But whenever I'm looking at this particular mechanism of FDM, either LHS should be a super key or RHS should be a prime attribute. Okay. Is the second method clear, ma? All of you? Is the second method clear? Only one student in the class. What about others? Okay. Now take a look at the example. R with 5 attributes. I've already given here. R is having 5 attributes, and A implies B, B implies E, C implies D. These are the functional dependencies. A implies B, B implies E, C implies D. Now, I've directly taken AC plus is a candidate key. I can figure out that. So what are the things that are not in the RHS of the FDCs? B, D, E. I've got AC. Now AC reflection is AC, fine. A implies B, fine. B implies E, fine. And C implies D. So, right, looking at this AC using reflexive property, I can say AC is giving me AC. Then A is giving me B using the first functional dependency. So I've written B over there. B is giving me E using the second functional dependency, and C is giving me D. So I can say AC is the candidate key. Now, AC closure is my candidate key. Now, looking at the FDs, Okay, looking at the FDs now, what is LHS of the FD? A. Is it a super key? Is it a super key, Emma? Is A a super key or a candidate key? A is not a super key and B is non-prime. So it is a violation of this particular concept. A is not a super key and B is non-prime. So this particular relation, looking at the first FD itself, I can say that it is not in third normal form. It is not in third normal form. Okay. Now what I have to do is, what I'm trying to do is, what is the violation of 3NF is R1 I'm taking, in that I'm putting AB. This is the violation. Now, what I'm trying to do, A gives me B. Using the concept of B, I can find E. Using the concept of B, I can find E. So I'm including E over here. Can I try to find out any other attributes using A, B, E, Emma? No. So this is my first relation. Okay. Now, what are the dependencies over here? What are the dependencies over here? A implies B is one dependency, and I've got B implies E as one more dependency. Now, again, look at this two things. Is A a super key or B a prime key attribute? Is A a super key? No. B a prime key attribute? No. Is B a super key? No. E a prime key? No. So again, this particular relation is not in 3NF. So what I'm trying to do is I'm trying to again break this into 3NF. So this would be R11, which is AB, and R12, which is BE. Fine. Okay. Now, what is the second violation that is causing the? So I have solved this particular concept now. As of now, I have solved these two concepts. So what I'm trying to do is these two are covered already. Now next, C implies D. Is C a super key? No. Is D a prime key? No. Again, this is a violation. Fine. So what I'll do, my next table would be R2, which is consisting of CD. Now here I'll make C as the key attribute. No issues with this. There's no concept of transitive dependency. Okay. Now, once I'm done with solving all the FDs to be in 3NF, now I have to see whether the candidate key is existing in any of the table. Whether the candidate key is existing in any of the table, A, B, B, E, C, D. No. So what I'm trying to do, my third relation would be A, C. So this particular four tables are now in third normal form. This particular 4 tables are now in third normal form. Is it clear or any issues you have, ma? So this and this together would be my 3NF. Is it okay how you are breaking up into 3NF with the second method? Please respond, ma. After breaking into AB, BE, I didn't understand. Okay. Amma, see, Amma, whenever I'm looking at R1, I hope you are clear with R1, forming of R1. So since A implies B is a violation of 3NF, I'm making that into AB. Now using AB, whether I'm able to get any other attributes. Yes, I'm able to get E. Using B, I'm able to get E. So my relation R1 is consisting of 3 attributes. Now, what are the functional dependencies with respect to these 3 attributes? What are the functional dependencies with respect to these 3 attributes? In the table is A implies B and B implies E. So that is what I've written. So these are the FDs. A implies B and B implies E are the FDs. Now, again, what I have to see is whether A implies B and B implies E is satisfying the 3NF condition. Okay. Is A part of a super key? No. Is B a prime key attribute? No. So this is a violation of your 3NF. Now, again, looking at the second FD, is B a super key? No. Is E a part of prime key? No. Is it a prime key attribute? No. So both are causing violations. Now, since both are causing violations, what I'm trying to do is, again, the table R1 needs to be broken into pieces so that it would be in your 3NF. It would be in your 3NF. That is what I'm trying to do. R11 is the newer version, which is consisting of the first violation, and R12, which is consisting of the second violation. Here, A becomes the key attribute. Here, B becomes the key attribute. And the relation which is joining these 2 tables would be B, so that I'll be getting ABE. Is it clear, Shravya? Now see, Amma. Again, I'm not breaking this into pieces. I'm just working with a small example. Now, see over here. I've got a table, some random table, which consists of roll number, state, city. Okay, roll number 1, state is Punjab, city is Mohali. 2, Haryana, Ambala. 3, Punjab, Mohali. 4, Haryana, Ambala. And 5, Bihar, Patna. Now see, I just removed the roll number. Looking at the table, I'll say, what are the functional dependencies that are existing? Roll number implies state is the functional dependency. 1 second, ma. Okay, ma. Now see, roll number implies state and state implies city. There in the RHS is clearly roll. So I have to find out roll closure. What is roll closure? It will give me roll. Roll gives me state and state gives me city. Okay, I hope it's clear. Is the candidate it not an issue? State city is an issue, which is a violation of your 3NF. Why it is a violation? Because state is part of a super key or city is not part of a prime key. State is not part of a super key or city is not part of a prime key. Hence, it is causing a violation. See that? Not in third normal form. Not in third normal form. Now, what you can do, you have to break the table into pieces. Break the table into pieces and you have to fill it with the data. That's it. Okay. Now, look, ma. I'm taking a bit more of attributes. So my R is consisting of A, B, C, D, E, F, G, H, I, J. Look at clearly, Emma. AB implies C, A implies DE, B implies F, F implies GH, and implies IJ. Okay. Now, what are the things that are not present in your RHS? C is there, D is there, F, I, J. Along with GH. Okay. What are the things that are missing in RHS is AB. Now what I have to do? I have to find what I have to do. I have to find the closure of AB. What is closure of AB? AB gives me AB. AB together is giving me C. A individually looking at this particular attribute is giving me DE. Fine, sorry. DE is giving me F. F is giving me GH. And D is also giving me IJ. Fine. Is it okay? So AB becomes my candidate key. Now I have to see whether the given with the set of functional dependencies is in 3NF or not. Is in 3NF or not. Now looking at the first functional dependency, AB implies C. So AB is a candidate key, not an issue with that. I do not have any problem with AB implies C. Okay, so no problem with the functional dependency. Now A implies DE. Is A a super key? No. Is D a prime key? No. A is not a super key or D is not a prime key. Then this is causing a violation. This is causing a violation. Okay. Now, what I'm trying to do over here, see, I'm trying to form a relation R1. Already I've written over there, but again, I'm just telling you R1. R1 will be having what is the violation? ADE. Now, is ADE giving me anything, ma? A is giving me DE. Now D is giving me IJ. So IJ. Now what is happening? This particular FD and this particular FD have been covered. I'll just mark it with red. Okay. Now, is there anything else that I'll get? No. Now, what are the FDs which are being covered is A implies DE and D implies IJ. Okay, D implies IJ. Now, is this particular relation in 3NF using the following FDs? Is A part of a super key? No. Is DE part of a prime key? No. So this is a violation. Now what I have to do? I have to go with R11. What is R11? What is a violation? ADE. Fine. ADE, and becomes a key attribute. A becomes a key attribute. Now, second is Dij. Is D a super key? No. Is Ij a prime key? No. So the second relation would be R12 is equal to Dij, where D becomes a key. Now looking at this particular table, what is the relation? What is the FD over here? A implies DE. Now here, either this should be a super key or this should be a prime key. Now here I'm telling you this is A is a key here. So there's no problem with this. And here R12, D implies Ij. D is the key attribute. So a super key is determining non-prime key attribute, no issues. So R11 and R12 are in what? 3NF. Now looking at the other one, B implies F. Is B a super key? No. Is F a prime key? No. So what I'm trying to do, this is also a violation of your 3NF. That is, I'm working with table called R2. R2, what I'm trying to put, BF. Now F gives me, look here, B implies F and F is giving me GH. So I can write GH also. Now, what are the two FDs that are present over here? B implies F and F implies GH. Right? B implies F. Is B is part of a super key? No. F is a candidate prime key? No. Then what I have to do? Again, I have to break this into pieces. R21, EF, B becomes a key attribute, and R22, I've got GH. Okay, I've got GH, only GH. But what is missing over here is F implies GH. So I have to have all the three attributes over here, where F becomes a key attribute. Now, these two tables are again in your 3NF. There's no more violation with respect to R21 and R22. No more violation. Okay. Now, what is left out, ma? AB implies C. AB implies C. It is not causing any violation, but that should be included. So my R3 would be, I'm just writing over here, R3 would be ABC. Okay. This is ABC. So now R11, R12, R21, R22, and R3 are the decomposed versions of your R, which is in 3NF. Any questions, ma, regarding this? You can please ask. All of you. Now try to do this, ma. Try to find whether these two relations, 1 and 2, are in 3NF. If not, how you are breaking them into 3NF. I'm just giving you 5 minutes to do this. Try it out fast. All of you, try this down fast, ma. Yeah, right, Ma, Shravya. Are you getting my others? ABCAI, ABCAI, right? ADGHHA. Right. 72, it's right, Ma. Is there any problem with 3 and F, Ma? The others? Explain the second question. Which one, Ma? The one which I've given now? Surya? Yeah, okay. Right, Ma. See, firstly, you have to figure out the candidate key, Ma. And I think all of you know how you figure out the candidate key. So, candidate key is ABD, right? Now, looking at the FDs, looking at the FDs, see, I'm working with the first FD, AB implies CMA. Is AB part of a super key? No. Is C part of a prime key attribute? No. So this is causing a violation of your 3NF. So what I'm trying to do is I'm trying to work with R1 with ABC. Okay, R1 is ABC. Now ABC is this particular attribute is giving me any other C? Yes, A implies I. So I can even write I. Right. So what are the FDs that are being covered? AB implies C, followed by A implies I. Okay. Now, AB implies C. AB implies C is 1 and A implies I. Is AB part of super key? No. C a prime key? No. So what I'm trying to do? I'm trying to break this into pieces. I'm trying to break this into pieces. AB implies C is giving me R11, which is nothing but A, B, C is 1. And then I have R12 as CI. Sorry, what is that? A implies I, right? AI. So this way. So here what is happening? AB implies C. My AB is the key attribute, not an issue with that. Here R12 is A implies I, A becomes my key attribute, not an issue with that. Okay, now looking, so this particular FD is clear, which is in 3NF, and this particular FD is clear, which is in 3NF. Now I'll go with the next FD. What is the next FD over there? The next FD is ADGH. Is AD a super key? No. GH a prime key? No. So what I can write is R2 ADGH, fine. And is there anything I'm getting, Ma? H is giving me J. So I can say J. Here what? AD implies GH and H implies J. Okay. Fine. So AD implies GH. Is it a violation of 3NF? Yes. Why? Because AD is not a super key. GH is not a prime key. So what I'm trying to do, my R21 would be ADGH and my R22 would be H implies J, which is nothing but HJ. So this way you have to look for the remaining one, which is nothing but your BD implies EF. Okay, there BD implies EF. BD would be the key attribute. And lastly, you have got R4, which is nothing but ABD. Fine. Is it okay, Surya? Or still any problem? So this is about your 3NF, the two ways in which you can work with your 3NF. And then you have Boyce chord normal form. You have Boyce chord normal form. Okay. Boyce chord normal form is a strict version of your 3NF. It is called as a strict version of your 3NF, and a relation is said to be in BCNF. A relation is said to be in BCNF if and only if all the determinants are candidate keys. If and only if all the determinants are the candidate keys. So what do I mean by that? If at all I've got a FD called A implies B or C implies D, okay, then this particular relation R ABCD is in BCNF. This particular relation ABCD is in BCNF if for these two functional dependencies A and C are the candidate keys. A and C are the candidate keys. Okay, this might be in your 3NF, not an issue. This might be in your 3NF. It might be in your 2NF, but this particular relation RABCD is not in 3NF until all the determinants, which is nothing but the LHS of the FD, are candidate keys. You cannot say that that particular relation is in your BCNF. Is in your BCNF. Okay. Now try to find out the highest normal form of a relation ABCDE with the given set of functional dependencies. With a given set of functional dependencies. Find out the highest normal form of a relation R ABCDE with FD set as BC implies D, AC implies BE, and B implies E. Try to find out that. Any questions with 3NF and the definition of BCNF, ma? And finding out candidate keys. So these are the three things what we have covered today. Any issues? Please respond, all of you. Okay, try doing that last question, whatever I've given you. After that, I'll switch on the activities for you. Did you get that, ma? What about foreign BCNF, Surya? Did you try looking for BCNF? Okay, so I have started 4 activities, ma, and a quiz also, you can work with that.